Good morning, students. Welcome you all to the today's IIT and NEET Foundation or Focus C program by the Mastermind Schools and the Krishnaveni Talent Schools. So once again, I welcome all the class 8th students for today's session. As you can see on the screen, my subject is physics. We are in class 8th, our ongoing chapter, Kinematics. And today we are entering into the session number 3. So far we completed 2 sessions on kinematics. That is on Tuesday and Friday. Again, today we are entering for the 3rd session. So last 2 sessions we learned about what is kinematics. That is how it came out from the motion. That is from mechanics. And what it deals with. Because kinematics is a branch of physics or branch of mechanics, deals about the motion of a body without considering the cause of motion. So whenever body is in motion, we'll come across so many terms. That terms we'll discuss. What kind of terms will come across when the body is in motion? What is the difference between the terms? And after that, what is the relation between the terms, which gives some equations. Right. So we'll continue where we stop in the last class. Okay. So we'll move. Right. So this is the already you have seen. There's a first classification. Exactly before knowing about kinematics, we should know mechanics, which is classified into 3 branches. 3 branches. First one is kinematic, study about motion without considering the cause. Dynamics, also study about the motion with considering the cause of motion. That is force. Study of force. Statics, when the body, study about the body as rest. Okay. These are the 3 major branches of mechanics. Mechanics is the again branch of the physics. Okay. After that, we discussed about the definitions. What is the kinematics? What is the dynamics? All clearly given for you. You already written in your notebooks. Right? After knowing about this, next we'll move to the very important one, that is all these physical quantities. So we have seen in the last chapter, in the first chapter of measurements, all the physical quantities which can be measured. All the physical properties which can be measured are called physical quantities, right? They are called physical quantities. We discussed about so many physical quantities in the earlier chapter. That is, there are 2 types. One is fundamental and the second one is derived. Right? But same physical quantities, the same physical quantities are further classified into scalars and vectors. This is another important classification. Right? The first classification is fundamental and derived. What we learn in the measurement chapter. Same physical quantities, maybe time, mass, length, whatever it may be. They are classified into scalar or vector based on whether they have magnitude, based on magnitude and direction. Very important one. Based on magnitude and direction. Magnitude and direction. All the physical quantities are classified into scalars and vectors. Sangareddy, why you are unmuting you every time? You are disturbing others. Okay. So scalars and vectors are the classifications of physical quantities which have them based on the magnitude and direction, right? So we'll see what is this. First one is scalars. A scalar quantity has magnitude only, but no direction, right? So for example, a mass of an object is 50 kg. So this 50 is called Balanpet. What happened? So The 50 is called magnitude. Magnitude is nothing but number. Magnitude is nothing but number. Magnitude is, so the number, every physical quantity will have that number, right? Every physical quantity will have magnitude, right? But there are some quantities that have the direction also. A vector is a quantity has both direction as well as magnitude. So the physical quantity having only magnitude is called scalar quantity, which has both magnitude and direction is called vector quantity. Second point, for scalars, normal rules of algebra are applicable. So you are understanding what is algebra here, because this is purely connected to mathematics only. So you know vector algebra, you know algebra is there in mathematics. So these scalars will deal in the regular algebra. Whereas for vectors, only vector algebra is applicable. There is separate branch in mathematics called vector algebra, which deals about the vectors which has both magnitude and direction. For example, your vehicle is traveling with a speed of 50 km per hour towards east. Towards east, I told. So what is the meaning? This 50 is the magnitude, as the towards east is the direction. Then that is the speed is called, with the speed of what 50 km per hour towards east we are mentioning, means we are mentioning the direction. So it is a vector quantity. Where you are mentioning the direction also, it is termed as vector quantity. If there is no direction, it is a scalar quantity. Right? Now third point. Right? Scalar quantity can change in terms of magnitude only. So how can you, for example, you can say mass of Anil is 30 kg, whereas Sunil is 50 kg. So as the number is changing here, that is magnitude is changing, the scalar quantity is changing. So change of scalar quantity can be identified only by number or only by magnitude. But whereas vector quantity, it changes in terms of either magnitude or direction or both. For example, I am telling, if direction changes also, vector changes. If magnitude changes also, vector changes. If both changes also, vector quantity changes. Right? For example, you can see. So speed, the speed of vehicle is 20 km per hour towards west. Is a one statement. It is 30 km per hour west. So what happened here? What is changing here? Magnitude is changing. Direction is same. So when magnitude is changing, automatically vector changes. Suppose the magnitude is same, but the direction changes from east to west to east. So 20 km per hour towards west, 20 km per hour east. So I also changes. Suppose both changes, also vector changes. So change of vector depends on magnitude, direction as well as both. Whereas change of scalar changes only on the magnitude, because it was only magnitude, no direction. Then the resultant, what is resultant? Final. The resultant of two scalars will always be scalar. What is the resultant means? You know, in mathematics, there are four operations are there. Four operations. That is addition, subtraction, multiplication, and division. Right? So whenever two scalar quantities are added, subtracted, multiplied, or division, the resultant is always scalar only. When you add two scalar quantities, result is scalar. When you subtract one from other, resultant is scalar. When you multiply two scalar quantities, answer is scalar. When you divide two scalar quantities, answer is scalar. That you can see in the algebra, regular algebra. But in case of vectors, the resultant of two vectors can be either a scalar or a vector. So when you are adding, subtracting, multiplication, or division of the vector quantities, two vectors, The result sometimes will come scalar also. For example, most important example is work. Work is equal to force dot displacement. This is called dot product. In case of multiplication, dot is there means dot product. So you know force is the vector quantity, displacement is a vector quantity, but work is a scalar quantity. Work does not have any direction. So this will come across in higher classes. When you go to the higher classes, you learn more and more about the vectors and scalars, especially in 11th standard. Okay. So last point, examples are given. Examples of scalar quantity: mass, length, time, etc. Examples of vectors given: velocity, acceleration, etc. Okay. So note down all these things. Write on the table in your notebook as it is. Take 5 minutes of time. First, so make it fast. 25 points are there. Once again, I request all of you join in time and don't unmute your voice to it will disturb others until unless you have anything to ask me, right? Always keep in mute position. So those who missed the classes, they can see the recorded sessions which we are sharing in the group immediately after the classes. You can make use of that recording classes to understand. Have you done? So after knowing about this, means first we started with the what is motion. We already learned in the previous chapter. And then we have seen what is kinematics. So whenever body is in motion, all the physical quantities we have to classify in terms of scalar quantities and vector quantities, right? Scalar quantities, vector. After knowing about scalar and vector, we should know about some terms, some pair of terms which come across when body is in motion. Means every body, moving body will cover some distance, displacement, it has some speed, velocity, acceleration, deceleration, and it takes some time. All these are the different physical quantities we come across when body undergo motion. So we have discussed about such kind of terms and the differences between them. Then we can go for the mathematical formulas, equations. Okay. So I am moving for the next part. The first physical quantity which come across in bodies in motion is distance and displacement. So why I am giving this table form is easy to understand. So instead of discussing separately about distance, separately about displacement, we get confusion. So I make to make it easy. So generally in common words, distance and displacement look same. It looks the same. For example, see, before explanation, I'll tell you. So for example, you are starting from somewhere. Okay. Say you are here. Suppose you are at point A. So your destination you have reached here. This is Hyderabad. This is Vijayawada. Right. Right. So Hyderabad to Vijayawada, you can directly go from here to here. Or there is some place called C. Say Kodar. Example I'm telling. So you can go like this also. So there are so many ways to move from A to B. A to B directly you can go like this, or A to B you can go from C to B also. For example, simple example I will tell. Suppose you started from your house morning time. As you know, school timings are 8:30. Generally you start 8:20 or 8:25 commonly. So what you do, you go directly to school only. You don't go here and there because school time is sharp. Your PT sir is very strict. So morning time you never move anywhere, directly go. But after the school hours, morning after 3:30 or 4:30, what you will do? You won't go straight. You go to some of your friend's house, move here and there. I'll go to some ground, cricket ground. Then you'll go to your house. Means to go to your house from school, there are so many ways are there. So many routes are there. So if you go directly, that is called displacement. That is the shortest route from school to your house is called displacement. And the total path remaining, suppose you are going from your school to your friend's house and then you come back to home, then that is called distance. The total length of the path you covered is called distance. And shortest path is called displacement. I asked you, where is your nose? You can show directly, this is my nose. This is displacement, shortest. You can show like this also. That is distance. Right? Got it or not? That is the experience. So many things are there about know about the. See, these two terms look same, looks alike in our daily using words. We thought that both are same only, but no, there is a big difference between. So every body when it is moving, every moving body will has its covers one distance or displacement. Right? Now kids, see when you are playing caroms, when you are hitting the coin to striker, sometimes you hit straight, sometimes you hit the crossway. You hit the frame and then it goes to the hole. So many ways you can hit the coin with the help of the striker. So some that is called, one is distance, other is displacement. The total length of the path. See the difference. Very interesting difference is there between those two. So distance is the length of the path traveled by a body while moving from initial position to final position. So one place to another place, how much total length it is covered is called distance. Whereas the shortest distance between the two initial and final position is called displacement. The shortest route. Short route we can call it. So suppose when you are searching in Google also, you want to go from place to another place, generally we will search for the short route. Okay. That is called displacement. Next, distance is a scalar quantity. Already we discussed about scalars and vectors. Means distance has only magnitude, no direction. Whereas displacement is a vector quantity. It has both magnitude and direction. Because displacement is nothing but moving in a particular direction. Distance is always positive because it's not having direction. If any direction is there, if it comes in opposite direction, it can get negative. As there is no direction, distance is always positive. Displacement can be positive or negative depending on the reference. Even you can see, even it is zero also, there is possibility. Even zero. Not only positive, negative. Suppose here is there. You are moving A to B, displacement. Body is moves this direction. It is covered 2 kilometers. Again came back to A again. Again 2 kilometers. So what is the length? Total distance covered? Distance is 2 plus 2 because total length. What about displacement? 2 minus 2. Why? Because it is positive one direction 2, opposite direction minus 2. That is 0. Displacement is 0. Displacement can be 0 when a body comes back to its original position. But distance cannot be 0 because it's total length. Okay. Fourth point. The total distance covered is equal to algebraic sum of the distances traveled. For example, there are so many points are there: A, B, C, D, E. So this is A, B, C. Example I'm taking, that's all. D, E, A to B, B to C, C to D, and D to E. And again E to A. So what is the distance? Suppose 1 kilometer, 3 kilometers, 2 kilometers, 4 kilometers. What is the total means? You have to add sum of the algebra. 1 plus 3 plus 2 plus 4. Means sum of the individual displacements are known as the distance. Sum of the algebraic displacement. Algebraic means sum. Algebraic sum. In case of displacement, the net displacement is a vector sum of the individual displacements. Vector sum that depends on direction, whether to take positive or negative. For the distance, there is no negative, so you can take directly adding. But in case of displacement, you have to see whether the body is in same direction or opposite direction. But in same direction, you have to add. With opposite direction, you have to subtract. Fifth point. There is always a distance covered whenever there is a motion. When a body is in motion, definitely it covers some distance. Displacement will be 0 if the body comes back to its initial position. I already explained. So, unit of distance is meter and displacement also meter. Meter or centimeters or any other units. So, these are major differences. Two important terms come across when a body is in motion and main differences between them. Okay, note down first. All of you note down as it is table. 6 points are there, make it quick. So that some more terms are there. All the terms we have to know, then we can go for the equations of motion. That is a major part of kinematics. Right. So these are the two important terms which come across when a body is in motion. Every moving body covers some distance, has displacement. So after this, we'll come across speed, velocity, acceleration, negative acceleration, then equations of motion. So as fast you can write, you can move to the next part. Make it fast. See, repeatedly read the sentence, you can understand much more clearly. So we discussed about vector and scalars. Then today again we are going for distance and displacement. It's a part of kinematics. Can't you hear my voice? I think I kept my voice is very high. Good morning. Hope you all can hear my voice, na? Completed? So make it fast, fast. You can respond through text instead of unmuting yourself. We complete, we'll move to the next topic. Next two terms we are discuss about speed and velocity, then acceleration, retardation, and finally we go for the relationship between all these terms, which are known as equations of motion. Right, I'm moving. Next is about the difference between speed and velocity. See, both are the terms which are sound same. They sound same, right? They sound same, but there are differences there. How you classified them into scalars and vectors in the same way, based on that magnitude and direction, whether they have both magnitude and direction or only magnitude. Based on that, they are classified into speed, velocity, the two physical properties. The two physical quantities are differ by their magnitude and direction, just like distance and displacement. So distance traveled by a moving body per unit time, that is distance by time, is called speed. See, speed is in terms of distance. Velocity is in terms of displacement. That is, distance by time is called speed. Distance by time is called speed. నాకు మంచిగా వస్తుంది ఇక్కడ. So it is clear from my side, or you don't know, madam? Is it clearly? I'm indicating also. Once, okay. So distance by time is called speed. Displacement by time is called velocity. What called? So see, we have seen what is distance, what is displacement. And the speed is represented in terms of distance, right? Velocity is represented in terms of displacement. So the rate of distance or distance by time is called speed, and rate of displacement, that is displacement by time, is called velocity. So as you know, as the distance is scalar quantity, speed also is scalar quantity. And as displacement is vector quantity, velocity is a vector quantity. Okay. Average speed of the moving body cannot be zero. We cannot take the speed as a zero, just like a Whereas average velocity of the moving body can be 0. Total distance by total time. You know how the displacement can be 0, velocity also can be 0. Speed of a body is always positive, just like a distance. Velocity of the body can be a negative also. Because there is direction is there. The negative will come when there is a direction. When there is a direction. So anyone, can you hear me clearly? All of you? Can you hear me? I can see my voice modulation. Okay. So speed indicates how fast body is moving. What do you mean by speed? How fast you are going. You can see speedometer, either in 4-wheelers or 2-wheelers. You can find speedometer where you can check the speed. Velocity indicates how fast body moves in a definite direction. So in case of speed, we are not seeing the direction. But in case of velocity, we can see how fast body is moving in a specific direction, in a particular direction. Right? Speed has only magnitude, whereas velocity has the both magnitude and direction. Speed with direction is called velocity. Speed with direction is called velocity. Got clear? So this is the difference between the speed and velocity, which are another important two terms. After distance and displacement, when a body is in motion, every moving body will have speed or velocity. It is a speed when there is no direction is mentioned. When direction is mentioned, it is termed as a velocity. Okay. So speed and velocity are also two twin terms, like distance, displacement. Twin terms which sound same, but there is a big difference between them. Okay. Right. So note on this first, speed and velocity. If any possibility, I'll make it big. Just a minute. Okay, not more than this maybe. Yeah, right. Okay, no issue. Distance first, under speed you can write down. Distance traveled by moving body per unit time is called speed. Distance traveled by moving body per unit time is called speed. Displacement traveled by a moving body per unit time is called velocity. Displacement traveled by a moving body per unit time is called velocity. It is a scalar quantity. That is, speed is a scalar quantity. Under velocity, it is a vector quantity. Third point, average speed of a moving body cannot be 0. Average velocity of moving body can be 0. Because direction will come, na? 3 kilometers will come, 0 it becomes. Total distance can be 0. Total displacement can be 0. So definitely velocity also can be 0. Speed of a body always positive. Velocity of the body can also be negative. Either it can be positive or also be negative. Speed indicates how fast body moves. Velocity indicates how far body moves in definite direction. And last point, speed has only magnitude and speed including direction is velocity. Means velocity has both magnitude and direction. Speed plus direction is called velocity. Speed minus direction is called speed only. Right? So, next class, we'll discuss about some more terms like acceleration, deceleration, that is also called retardation or negative acceleration. After that, we see how these all the terms are related, like distance, displacement, speed, velocity, acceleration, negative acceleration, time. All they are interrelated. We can form some equations by combining them, which is a major part of kinematics. There are 4 equations will come. Of course, we'll discuss about 3 equations this class. Okay. So that is acceleration, retardation. We'll discuss next class, followed by. So these are the equations of motions. We'll come across later. Okay, these are closing time. I don't know why they are joining. So these are the so many equations are there. Right. So next class we'll discuss about the acceleration, retardation, followed by equations of motion, derivations are there, and some example problems we can discuss in the worksheets. Right. So for today, our DPP, daily practice problem, just like homework. Note down the question. Differentiate between distance and displacement. That is the tabular form. So already written. Once again, you write as a recall in your notebook and take the corrections from your teachers. Right. So that's all for today, students. Thank you very much, all of you. Have a wonderful day. Thank you. Thank you, all of you. All of you, can you hear me?